Hi everyone, welcome back. So this is the fifth video in this series that I am recording about using the R programming language to conduct data science tasks and data analysis tasks. So in the previous few videos to this, I've covered some basic stuff. We're still covering the basics here, foundational ideas and things you'd need to know. But we started off by installing R in our studio and getting that set up, and then we covered installing packages and how to load them. And then in the last two videos, I talked about some of the most common data types that you encounter when you're doing data analysis using R. In those videos, I used data, but I used data sets that were built into some of the packages in R that I was using, such as the tidyverse. But usually when you are conducting data analysis or you're doing some sort of data cleaning, you're using your own data. So you know, if you've conducted some research, you've collected some data, that's the thing you're usually interested in analyzing. The built-in data sets are good for kind of practicing your skills or teaching yourself how to do certain types of analyses, but mostly you're going to be interested in analyzing your own data. So in this video, I'm going to talk about how you load data sets from some common file types. So the ones I'm going to focus on are comma separated value files or CSV files, and Excel spreadsheet files, or what were XLS files and more recently xlsx files. So they're a couple of the most common file types that people use for storing data in rows and columns, essentially. So that's what I'm going to focus on here. So the first thing I'm going to do here is kind of read in some data from a comma separated value, a CSV file. So my preference is when importing data into R or into Python or other libraries, other programming languages, is to work with CSV files. They tend to be small and they're quite easy to work with in R and other programming languages. Okay, so what I've done is I've got a couple of data sets that I have saved as CSV files in the folder on my computer that the project I am working in points to, essentially. So you can see up here it says, if you look on the right, like the top right of the screen, it's got R data wrangling. That's the name of the project that I currently have open. So I have an R project that I've set up, open and running, and that project is saved in a particular folder. So it has a file, it has a path through the Windows file system, and in that same folder I've got some data sets. It's important that you have the data sets in the same place as the project, because otherwise if you run these commands to try to import them, R's not going to be able to find them unless they're in the correct folder, in the correct kind of working directory. It's not going to be able to find them. It's not going to search through your whole computer looking for them. So if you have a project you've created, make sure you've saved your data sets in the correct place. So the same kind of relative path, so to speak, in terms of folders. So you can, when you run these commands to load the data, it works. Okay, so let me start with this. If you look at line 8 here, I have this. I'm creating a new object called D for data frame. And I'm using the assignment operator. That's that less than minus sign, that kind of backwards pointing arrow that's used as an assignment operator in R. So I'm creating this object using the assignment operator, and what I'm assigning to that object is all the details here, this syntax on the right. So I'm using this command of read.csv. Okay, so I'm telling it I want to read in a CSV file. And then in parentheses, as a string containing double quotes, I've put the full name of the file. So it's called mtcars.csv. So this is kind of a quite commonly encountered data set. It's data on different models of cars, I think collected from a magazine or publication called Motoring Times in the 70s in the US, and it's kind of often used as an example data set. So I thought I'd just work with this one just as an example. And I've got mtcars.csv, I've got a CSV with that data in, saved in the correct folder on my desktop. so that when I run this command, it should be able to find it and load it up. So I'm going to create this object D, which is this new, by importing the empty cars data set. And you can see now, if you look at the command line below, it's printed the command that I've just run. But if you look in the top right in the environment window, we've now created this new object D. You can see there, if I hover near it, it's a data frame. It's got 32 observations, so 32 rows and 12 variables. Okay, so 12 features in the data that have been recorded. So that's worked, that's imported that data. You can't see it when you're working with data in programming language such as this. You're not immediately looking at it. You can inspect it, you can look at it, and we'll look at that. We'll look at how to, we've talked about how to do that previously using view. So we could use view and then put D in parentheses, and it will show us what the data looks like. It will give us it shows kind of like the spreadsheet sort of presentation of that data is probably the best way to describe it. But what we've done, we've got our data, it's loaded the CSV, and if I run this class, we already know, because if we hovered here and it told us it was a data frame. If I run this class command on D that's in line 10, you can see down below in the command line, it's telling us that it's a data frame, so it's saying data.frame. Okay, so another useful command, so we'll just run through a couple of useful commands for like how you can interrogate your data. So in the previous video, we looked at a command called glimpse, which gave us like a summary of the different variables in our data set. A very similar command is this str command or function. And it's the str, I think, is short for structure, so it shows us the structure of the data. So if we do str and then we put our D data frame object in there, if I press Control and Enter and run that command, you can see below in the output, in the command line where it's given us our output, we've got a number of columns and it's summarizing our data for us. It says it's a data frame. We've got 32 observations, 12 variables. The first column there, it's showing the name of each of the variables. The second column there is that it's telling us the type, the data type of that variable. So character, numeric, integer, that type of thing. Another thing we can do if we've got a big data set with lots of features, lots of variables, we might want to print out what all the different variables are. And a command we can use for that is col names, or that will show us the column names for the variables. So if we run col names on our data set D, you'll see it give us just this kind of list of each of the variable names as a string contained within double quotations. So you can see there, we already had this information above, but it's just kind of another way to obtain it if you didn't need all the other stuff. We've got model, MPG, cylinders, displacement, horsepower, etc. So as I demonstrated in the previous video, we can also select specific variables to look at from our data frame. And the syntax for doing that is we specify our data frame, we use the $, and then we specify what the variable is. So if you look at line 16 here, what I'm doing, I'm saying D, our data frame D, from D, then using the $, I'm saying select HP, which is the horsepower variable. So if I run that, what it should do is just give us a printout of all the horsepower values. So they're 32 in total in this data set. And you can see it's done that. I've run that command below, and you see I've got 110, 110, 93, 110. And you'll see that they match. It's printed out those values when we did our structure command above, and they match that. But it's shown as all the values contained within that particular variable. So that's kind of how to import a CSV. Notice here I didn't load any packages to do this. So importing data from CSV seems to be covered by the base and the base stats packages within R. So it's very easy to do. You're not having to install any other packages and load them in if you're working with comma separated value files. So it's useful to know. So what we'll look at next is reading data from an Excel spreadsheet file. So an XLS, a file that ends with the extension XLS or xlsx. So to do this, you need to install a package called Read Excel. There are a couple of packages you can use to you can install and use to read in Excel spreadsheet files. Probably the most commonly used one is read Excel. Okay, so I've commented out, I'm just going to uncomment it so you can see it there. I've got this command here, install.packages, and then as a string, in quotes, I've got read Excel. I've commented that out because I'm not going to run it because I've already got it installed. But I do need to load it, so I'm going to use the library command and load that package so I'm able to use it. So that's worked. It's printed below in the command line. It's returned our command line prompt. You can see from the little arrow there. Okay, so what I'm going to do this time is I'm going to read an Excel file in, an Excel spreadsheet in. The one I'm going to use it's a dataset called Titanic.xlsx. Again, it's in the same folder on my computer as I have set up this art project that I'm working in. Okay, and that's data. That's another commonly available sort of open source data set. And it's data from the Titanic about the passengers, what their name was, what class of cabin they were in, whether they survived or not, what their age was, what their sex was, things like that. It's quite, you encounter it a lot when you're doing data science tasks. It's being used quite commonly in machine learning competitions and things like this. But what I'm gonna do is I've got a copy of that data set saved as an Excel spreadsheet. I'm going to read that in, and I'm going to create a new object called df for data frame. I'm going to use the assignment operator, and in order to read in the Titanic data, I'm going to use the command read_Excel, and then I'm passing in parentheses, I'm passing within double quotes the string for the full name of the file, Titanic.xlsx. So if I press Control and Enter to run that command, you see it prints out below in my command line. Sorry, I just paused there because it took a little while to appear in the environment. It's printed out the command below in the command line, but if we look up in the environment, you see there we have a data frame called df. It's actually shown as a Tibble data frame, which is a simplified type of data frame that you get when you're working in R. It's got 881 observations and 12 variables. So that's loaded that in. We can have a quick look at that using the head command. So it's got a lot of rows of data, and I don't really want to print them all out in the command line, so I don't want to see them all. But what I can do is I can use the head command to just get the first six rows or so. That it'll give me the column names, the headers, and then the first few rows of data essentially. And the syntax for that in R is you type head, and then in brackets you put the name of the data frame that you want the head for. So if I run Control and Enter, that should run that command, and you can see underneath here is the first sort of 6 rows of data from the Titanic data set. So we've got, like you can see, it's telling us what it is as well. It's telling us it's a Tibble. As I said, I'll go into more detail on what that is in future videos. But a Tibble, it's a simplified type of data frame that's kind of easy to work with in R, and it's giving us some of the names of some of our variables: passenger ID, whether or not they survived, passenger class, the name of the passenger, their sex, age, etc. Fare. There's some NAs here, so there's some missing values, which if we were analysing this data, we'd have to deal with those in some way. And you can also see it's given us the data types underneath the headers there, so double precision, character, things like that. Some of these we're not going to want as double. Look, if you look at survived, this is something I mentioned in a previous video. You import your data, R tries to interpret what type of data that is. Sometimes you're going to need to it's going to be wrong, you're going to need to change that. So survived as 0 and 1, and it survived is either yes or no, they survived or they didn't. So it's a categorical variable that's been given like a dummy code essentially, but it's identified it here as a double precision numeric variable, so a floating point variable. We'd obviously want to change that to a factor, to a category at some point. We're not going to worry about that now, because all we're interested in this video is importing data sets. In future videos, that's something we'll get onto, is how to tidy up and get your data into some sort of good order so you can do what you need with it. Okay, so a couple of things I'll draw your attention to. the command I used above was quite simple. I just gave the name of the file and it imported. There's only one sheet to that file, so it imported the sheet that I wanted. But if you've got an Excel spreadsheet with multiple sheets to it, so your file it's got sheet 1, sheet 2, sheet 3, it's got a number of different sheets. They might be called different things. You might have named them different things. You can specify which sheet you want using either the name or the number. And to do that, I've commented out, let me uncomment it so you can see it. But what you would do is, you'd do a similar sort of thing like that I did here. You'd give the file, you'd run the read Excel command, you'd give the file name as a string, and then you'd put a comma, and in the parentheses, you'd also put sheet equals, and then the name of the sheet. So if the sheet was called employee contracts or something like that, that's what you'd put in there. I'm not going to run that because I don't have a file with this name. It was just an example, but that's if you've got multiple sheets in the spreadsheet, you only want to import one of them, so you know which one it is you want to import. I think by default it would just import the first if you didn't specify this argument. But you can do a similar sort of thing here as well with by just giving the sheet number. So if you've got you've got your Excel spreadsheet, it's got multiple sheets within the file. You're importing that file, but you only want the second sheet from the file, the data that's on that second sheet. You could just specify sheet number 2, and that would work as well. Okay, not something we need to do here. I don't have any. I would have run an example of that, but I don't really have any Excel spreadsheets with like lots and lots of files within them. Okay, so last thing I'm going to demonstrate here though is another way to import your data from, say, a CSV or from an Excel spreadsheet. And to do this, I can read data from the clipboard. So if you copy data, so when you copy and paste data, what I'm going to do here is I'm going to copy some data from an Excel spreadsheet, and then I'm going to use a command to read the data in from the clipboard where it's saved on my computer. Okay, so let me demonstrate that first of all, so you'll be clear what I'm doing. So here I am. This is the spreadsheet that I've got open. This is my data set. It's a small data set. It's called consumption example. It's got 3 variables: anonymity, information consumption, and it's got numeric data for, I think, 50, about 40 something variables. I'm going to do Control and C to copy that. So I've copied that, and if I could paste it into another spreadsheet or something like that. But what I'm going to do now, I've got that copied. It's saved on the clipboard on my computer. What I'm going to do is I'm going to import it directly into R by using this command here. I'm going to import it as an object called data. I've just given that the name data, so it's different from D and DF that we've used above. I'm assigning that to this object. But what I'm doing is I'm using this command called read.table. Okay, so if I do read.table and then in parentheses, I use this argument file equals, and then as a string within double quotes, I'm saying clipboard. So the file is going to be whatever is currently copied to my clipboard in Windows. Okay. Then I've got a comma, and then I've got this argument sep equals, and then in double quotes again, I've got like /t. Okay, so this is the delimiter or the separator. It's saying separate the data, and in this case, it's using tabs. So it's tab separated data that's come from an Excel spreadsheet. So I believe if you're importing copying data from CSV file in this way, you'd probably have to change this to just a comma. So you'd have to replace this /t with a comma. And then I'm saying header equals true. So what I'm doing here is telling it to include the header of the columns, essentially. So if I run this command, you see there, it's printed the command below in the command line, but it has also created our object up here. So data So data frame, we've got 48 observations from 3 variables. That sounds about right. Well, let's have a look to see if it has worked correctly and imported that data. So I'm going to use the head command on that object, and you can see the first few lines. So it's got our three variables: anonymity, information consumption, and it's got the numeric values associated with those. Okay, so that's another way to do it. We've used a couple of packages here. Well, we've used one imported package in particular, but we've used a couple of methods. We've imported CSV files, we've imported Excel spreadsheet files, and we've also seen how if you copy and paste a load of data from a spreadsheet, you can also import it directly from the clipboard into R to work with. Okay, so that's as much as I'm going to cover in this particular video. It's longer than I intended, as they always are. In future videos, we'll go on and we'll start looking at, now we've got some data imported, how we're going to tidy and clean it up. So we want our data to be tidy with observations or participants in rows and variables in columns. We're going to make sure it's in good order so we can actually run useful analyses on that. Okay, hope this was useful. Thank you for watching and listening, and I shall speak to you soon.